we've had a lot of practice dealing now with linear equations, and we've captured the bear and got him up to the top of the mountain. We've built ourselves a boardwalk, and we can now go further on our hike. We've dealt some with equations, and you've done some skill sets. This particular page, section 1.3, has something kind of unique on it, and just a little bit of an interest. This 3x3 square that you see is called a magic square. No matter how you add things up, either horizontally or vertically, it always adds up to 15. So if I go 1 plus 5 plus 9, it equals 15. If I go 9 plus 4 plus 2, it equals 15. So no matter where I go, this thing is always equal to 15. Also, it's unique in the fact that if you take a look at it, it's known as a normal magic square. And by normal, it means that every letter or every number from 1 to 9 is represented. So if you look, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are all represented in that normal magic square. It looks a lot like a Sudoku, or Sudoku, however you say it, a square. If you've ever played that game where you have groups of 9s and you have to figure them out so that they all add up to having 1 through 9 in the square. In those, we don't worry about what they add up to. We just want to place all the 1, 2, 3, 4, 5, 6, 7, 8, and 9s in order so that everything works in relationship to being able to finish up the puzzle. Well, as you can see right here, I'm going to circle this. As you can see right here, there is an equation that you can use to determine what the sum of a normal magic square is going to be. S is what the numbers are going to add up to be, and the way you use this equation is that because we have a 3x3, n is going to be replaced by 3. So I'm going to have 3 times, oops, sorry, did that wrong. 3 times 3 squared plus 1 divided by 2. Now, what we're going to show you here is a little bit of an order of operation. We're going to do what's inside the parentheses first, and the exponents always take the first lead. And so the first problem we're going to do is this one right here. We're going to do 3 squared. So we've got 3 times, and remember we never use the x or the dot, we always use parentheses. 3 squared is 9 plus 1 divided by 2. We then do what's inside the parentheses first, right here. We've talked about that. So 3 times 9 plus 1 is 10 divided by 2. We then go 3 times 10 is 30 divided by 2, and that equals 15. And so that tells us, with the formula, what the sum of this magic square is going to be. And so down here it asks you to create a 4x4 and see if you can figure that out. And we're probably going to do that as a class to see if we can't make up our own 4x4 magic square. See if we can get the numbers to be placed in there correctly so that it will all add up to what 4 times 4 squared plus 1 divided by 2 is going to equal. Problem number 1. This is going to be something that you might do. You've got a bunch of DVDs, and you're all going to get together at a party and determine who has the most and who has the fewest, and how many does each one own, and how many are they all together. And so this is going to be a problem for you and your group to do a thought process and an elimination and determine how many DVDs each person has. I'll give you a little hint. Right here, it tells us that in one situation, we've got 182 DVDs right there. And by having that information, you should be able to come up with who has the most, who has the fewest, and what each one of them actually has. It does tell us that Dan has the fewest. Donna's got 7 more than Dan. Betty has twice as many as Donna. Jerry has 3 times as many as Dan. And Kenesha has 6 less than Donna. The thing that we don't know is how many Dan has. We know that he has the fewest. And in algebra, when we don't know something, we call it X. And you're going to build this whole thing around this letter X. And you're going to eventually add each of them up. And you're going to add up to 182. You have to understand what the word more means. It means to add. Twice as many means to multiply, and multiply by a very special number. Times is exactly what it says. Times means to multiply. And I think if more means to add, less would mean to subtract. And so you're going to write this huge equation out, and you're going to put x's in there, and then you're going to put coefficients in front of the x, and either a multiplication using parentheses, or an add sign or a subtract sign. In our case, we'll call them positives and negatives. And you're going to develop an equation, and down here you're going to use that equation and figure out how many each one of them has. Now, this is kind of a fun activity, and with your group, you ought to be able to solve the problem quite easily. Top of this page just finishes off the last question of the last section of problem 1. So now here's problem number 2. It's the same kind of thing. Instead of having DVDs, you're going to raise some money. And your idea here is to determine which one of these people, Henry or Harry or Helen, Hetty and Haley, which one of those are you going to call X? And it's the one that you don't know. And you'll be able to see that. You read through it. This is a chance for you to really, really get in and think about the process. Usually what happens in a math class is that you're just given a bunch of problems and you just work them. That is not the case here. You're going to have to work hard and solve them and think through which one's going to be X. And then, are you going to add some things to X? Are you going to multiply things to X? Are you going to subtract? Are you going to divide? What are you going to do with X as you work through this problem? Now that you've gone through and figured out what X is, you can now start to plug some values in, and that's what this problem number 5 is all about. It tells you that they raised this much altogether, $828.50, and so how much did each person raise? And again, you're going to plug that back into the formula that you've created in the first part and be able to figure out exactly how much, and that's what A, B, C, D, and E is going to, that's what the answer is going to be for those. Section 4, just a continuation of learning more about solving linear equations. We're going to give you some riddles, we're going to give you some thought processes, and allow you to, on your own and or with your group, work through these problems. I'm sure you've all played games in the past, Yahtzee or some board games. It's always good to play Clue. Game of Life is fun. Monopoly is a very long game that it takes you time to play. But all of those games take some strategy, and you have to think through them and do a process of elimination to determine who done it, whether it was Colonel Mustard in the ballroom with the rope. That's a matter of logic deduction on your part, and this is what you're going to do in this particular section. The book is pretty much up to date, so it talks about MP3s. MP3s are something that I'm sure most of you deal with. You've got MP3s downloaded on your phones. You carry them with you everywhere you go, and this ought to be right down your alley in terms of being able to understand the process. Just think about what you've done. If you have gone out and through your iPod or iPad or your smartphone, you've downloaded some music, chances are it's come down as an MP3, and we're going to just ask how many friends, you've got multiple friends, how many MP3s does each of these friends have? And now here we get to a practice set of problems, and we're going to solve these equations. So let me show you how to do this. Fractions seem to be a big problem for a lot of people, but let's see if we can't figure out a fairly simple way to help you understand fractions. We have stood in class and we've taught you that when you multiply fractions, you multiply them straight across. We've taught you about the fact that every number is a fraction, and so when you take a look at that 2 that's in front of the x, that really is 2 over 1. When you take a look at the 5, that really is 5 over 1, and so we're going to multiply straight across and do this problem. So I'm going to rewrite it. 3/4 times 2x plus 5 equals 14. We're now going to multiply, and we're going to use what is called the distributive property. Even though we haven't discussed specifically what it is, here's how it works. I'm going to multiply 3/4 times 2, and then I'm going to multiply 3/4 times 5. I'm going to distribute that throughout the whole problem. Well, there's a 1 right there, and there's a 1 right there, and you know that when we multiply fractions, we multiply top to top and bottom to bottom. So 3 times 2 is 6, 4 times 1 is 4, and the x comes along for the ride because we haven't done anything with that, plus 3 times 5 is 15, 4 times 1 is 4, equals 14. And now what we're going to do is we're going to undo this problem. We're going to subtract 15 over 4 from both sides, and then we're going to divide 6/4 on both sides. And when you divide a fraction, you know to turn it over and multiply straight across. Well, in order for us to do this, we've got to make a change to that 14. That 14 does not have the proper denominator. It's got a 1 underneath it. And when I subtract 15/4 from both sides, that doesn't work very well. So I need to get a common denominator. So I'm going to multiply 14 by 4. So 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5, over 4. And now I can subtract 15 from 56. And the denominators stay the same. So now what I've got is and I'm going to write this over here, 6/4 x, and the positive 15/4 and the negative 15/4 goes to 0. So this is then equal to 41/4. Okay? Now what I'm going to do is I'm going to multiply by 4/6. Put parentheses around it. 4/6. Put parentheses around it. This cancels out. Gives me my 1x equals the 4's cancel. And so I get 41/6. And that's my answer. It's not a real pleasant answer. It's not a real great answer, but it is an answer. I guess we could divide 6 into 41 and go 6 and 5/6 as our final answer, but 41/6 is sufficient for us. So being able to work with fractions, remembering the rules for fractions, I know it's difficult in math to remember rules. I understand all that. But there are just a few rules that I require of you, and when you get those rules down, math becomes much more easy for you, and math becomes a success for you. And that's really what we're looking at, is to get you successful. So I hope this definition or this example helps you, and then we can work on these together in class with your group. Here are just some more problems for you to work out, and again, this will be a group project. And we're now finished with Chapter 1, so these next few pages are just a summary. Again, we will work on these in school.
Call the front office, Mr. Edwards, the front office.
Oh, sorry about that interruption. Obviously, I'm recording here at school. And so if you will just work on these in class, we'll review them, and we're going to be ready for the test.